Here's the solution for number 1. The diameter of the planet Uranus is 10 times that of Mercury. If the sum of the diameters of the planets is 34,100 miles, find each diameter. One technique for solving a word problem is to figure out what part of the paragraph is actually telling you what to find out. In this case, it's find each diameter. So I can recommend that you box that or highlight that in some way. Another good solution technique is to read the paragraph more than one time and to somehow underline or highlight information that you think is key to the solution process. For example, the diameter of Uranus is 10 times that of Mercury. I'm going to underline that portion. Later on, I see the word sum, which to me means to add things together. So I might underline where it says the sum of the diameters. You can highlight or underline as many facts as you think are important. There are a lot of ways to solve word problems, but because this is an algebra class, we want to try to use algebra to get our solutions. This means to choose variables to represent the unknown information. Remember how I drew a box around find each diameter? That's telling me I want to find the diameter of Uranus and the diameter of Mercury. So I'm going to start my problem-solving plan by writing down those two unknowns. The diameter of Uranus and the diameter of Mercury. What I'm hoping is that I can create a plan that finds me these two results. I'm going to choose a variable to represent the unknown diameter of Uranus. How about the letter U? In my problem-solving plan, the variable U will represent the diameter of Uranus. For the diameter of Mercury, I'm going to choose the letter M. Once I've selected variables to represent the unknowns, I go back and read the paragraph again, paying attention to the facts and clues that I've underlined. The first sentence says the diameter of Uranus is 10 times that of Mercury. The word is in algebra is often an equal symbol. I can translate that sentence into algebra symbols. The diameter of Uranus is 10 times the diameter of Mercury. The second sentence can also be translated into algebra symbols because the word sum implies adding things. The diameter of Uranus plus the diameter of Mercury is 34,100 miles. Here are some equations created from the sentences in the paragraph. I want to solve these equations to figure out answers for U and M. This equation I wrote here has two different variables in it. That makes it hard to solve. However, we can use the substitution process to replace the letter with 10M. So where I have a U, I'm going to substitute 10M. Now combine like terms. This makes 11M equals 34,100. And divide by 11. M equals 3,100. We're halfway done. We have the value for M. Our other variable was U. And we have an equation that has U alone. So let's substitute again. Where the letter M is, fill in our result, 3,100. Therefore, U is equal to 31,000. The final step of solving any word problem is to make sure that the numbers you have are reasonable and that they have the correct units of measure to fit what was asked. We're asked for diameters, and the diameters are measured in miles. So we have to make sure that we write the word miles next to these results. So our diameter for Uranus is 31,000 miles, and the diameter for Mercury is 3,100 miles. Without the unit of measurement words, your answer is not fully correct. Problem 3. One tree is 7 times as old as another. 5 years from now, it will be 4 times as old. Find the present ages of the trees. I'm going to identify that as the part of the paragraph that's actually telling me what to figure out. We want to identify variables to represent the ages of the trees. And it might help to use a chart to help us keep track of when we're talking about the present age versus the age in the future. So over here on the side, I'm going to write the present age, or the age now. And then right underneath, I'm going to write the age in 5 years. Two trees are mentioned. The first tree, and let's call the other one the second tree. So you can see that this creates a chart with 4 boxes. In this chart, let's put our algebra expressions. Let's use a variable to represent the age of the first tree now. Perhaps we'll call that x. What's the age of the second tree now? We can get that from the first sentence. One tree is 7 times as old as the other. So we could call this 7x. In 5 years, the first tree will be x plus 5 years old. In 5 years, the second tree will be 7x plus 5 years old. This information came from the first sentence of our paragraph. We haven't really used the second sentence of the paragraph yet, so let's take a look at that. 5 years from now, that first tree will be 4 times as old as the other tree. The sentence is saying that the older tree is 4 times as old as the younger tree. This equation fits the second sentence of the paragraph. Now let's solve the equation. Do the distributive property. 4 times x is 4x, 4 times 5 is plus 20. Now we can subtract 4x from both sides to get 3x plus 5 equals 20. And subtract 5 to get 3x equals 15. Then divide by 3 to get x equals 5. Once we know the answer for x is 5, we can see that 7 times x is 35. Make sure you use the proper units of measure when you answer the question. The first tree is 5 years old. The second tree is 35 years old. Now number 5. A newsboy notices that he has 4 times as many dimes as quarters. If his dimes and quarters total $1.95, how many of each has he? I'm going to draw a box around that. That's what I'm actually asked to figure out. I'm looking for the number of dimes and the number of quarters. I'm going to use variables to represent these. Perhaps D to be the number of dimes and Q to be the number of quarters. Now let's read the sentences and create algebra expressions. A newsboy notices he has 4 times as many dimes as quarters. So his number of dimes is equal to 4 times his number of quarters. Now let's look at the second sentence. His dimes and quarters total $1.95. Let's write an algebra equation for that. 10 cents times the number of dimes plus 25 cents times the number of quarters is equal to $1.95. This equation has 2 variables in it, so let's make a substitution so we have only one type of variable. Where the letter D is, we can substitute 4Q. The next thing I'm going to do is multiply all terms by 100 to remove the decimals. This transforms into 10 times 4Q plus 25Q equals 195. You don't have to do that, but I'm more comfortable when they don't have decimals in the numbers. Now let's combine like terms. 10 times 4q is 40q, and that combines with 25q to make 65q. Then divide by 65. We get q equals 3. To find the answer for D, go back to our first equation and replace the q with the number 3. And we see that D equals 12. So we have 12 dimes and 3/4. It's important on a word problem that you clearly write the answer with the correct units of measure. Don't just leave it as D equals 12 and someplace else Q equals 3. That's not clear communication of what you're doing. Next, number 7. How many pounds of coffee worth 72 cents a pound should be mixed with 20 pounds worth 90 cents a pound to produce a mixture worth 78 cents per pound? Where's the actual question? It's here at the beginning. How many pounds of the cheaper coffee should be mixed with the other type to get the mixture that costs 78 cents per pound? So this is what we want to figure out. I'm going to select a variable to represent that. So the number of pounds of the 72 cents per pound coffee. Let's use the letter X. Now let's read the paragraph again and create an equation. 72 cents per pound times the number of pounds of that kind of coffee plus 90 cents per pound times 20 pounds of that more expensive coffee will equal a mixture that is 78 cents per pound. And there will be X plus 20 pounds of that mixture. X pounds of the mixture will be of the cheaper kind of coffee, and 20 pounds of the mixture will be the more expensive coffee. This equation models what that paragraph is talking about. Let's do the distributive property. At the same time that I'm going to do the distributive property over on the right side of the equation, it makes sense to also multiply these two numbers together here in the middle. 0.90 times 20 is 18. Okay, now the distributive property. 0.78 times x is 0.78x, and 0.78 times 20 is 15.6. At this point, we could multiply all terms by 100 like we did in the last problem to remove the decimals. Or we can continue as is, leaving the decimals and using a calculator to help us do the math. I'm going to leave the decimals in this problem. Next step, subtract 0.72x from both sides. 0.78x subtract 0.72x is 0.06x. Next step, subtract 15.6 from both sides. 18 subtract 15.6 is 2.4. Final step, divide by 0.06. 2.4 divided by 0.06 is 40. I have an answer for X, and X was representing the number of pounds of that cheaper coffee. So my answer is 40 pounds. Number 9, the measures of the sides of a triangle are given by consecutive integers, each indicating a number of inches. If the perimeter is 6 feet, find the length of each side. This is describing a triangle, which is an object that can be drawn. So a good problem-solving technique is to draw a picture of a triangle. We're not drawing the picture to scale, we just want to have a triangle to help us visualize what's going on. We're asked to find the length of each side. So we're looking for 3 unknown measurements. The first sentence tells us that these unknown side lengths are consecutive integers. So let's choose variables to represent these unknown sides, but label them on the drawing of the triangle. If the shortest side is represented by the letter x, then the next longest side will be the next consecutive integer, which is 1 more than x. And the longest side can be represented as x plus 2. The variables x, x plus 1, and x plus 2 is how you can show consecutive integers. The second sentence says the perimeter is 6 feet. So from that we can create an equation. Perimeter is the sum of all the sides of the shape. So let's sum our 3 algebra expressions and say that it is equal to 6. Now solve the equation. First, combine like terms. 3x plus 3 is equal to 6. Then subtract 3 from both sides. 3x equals 3. And divide by 3 to get x equals 1. We have found that the shortest side of the triangle is 1 inch. The next longest side of the triangle is 1 plus 1, or 2 inches. And the longest side of the triangle is 1 plus 2, which is 3 inches. Next, number 11. If the perimeter of a square is 36 inches, find the area of the square. Let me highlight that. That's the part we're actually asked to figure something out. This is talking about a square which can be drawn, so let's draw a square. We're told that the perimeter is 36 inches. What does that allow us to label on the square? Because a square has 4 congruent sides, for the perimeter to be 36 inches, each side must be 9 inches. We're asked to find the area of a square. We might represent the word area with the variable a. To solve this problem, you need to know how to find the area of a square, which is a geometry topic from middle school math. Area of a square is found by taking the square's length and timesing by its width. The length is 9 and the width is 9, so the area is 81. Make sure you give the correct units of measurement. Area is measured in square inches. Next, number 13. When a certain number is divided by 11, the quotient is 7 and the remainder is 5. Find the number. Let's read the paragraph again and create an algebra equation from the clues given. When our number is divided by 11, the quotient is 7 and the remainder is 5. When it tells us the quotient is 7 and the remainder is 5, what that's telling us is that 7 times 11 plus the remainder of 5 will equal our original number. Simplifying the left side, we get the result 82. Our unknown number is 82. If you divide 82 by 11, you get 7, remainder 5. Number 15. At 2 o'clock p.m., 2 cars start to meet each other from towns 240 miles apart. If the rate, which means speed, of one car is 10 miles per hour faster than the other, how fast does each car go if they meet at 5 o'clock p.m.? It may help to draw a diagram of this problem. Here's one town, and here's another town. One of the cars is leaving the first town and traveling this direction on its way to the second town. The other car is leaving the second town and driving this direction on its way towards the first town. We know that the total distance across here is 240 miles. The other information we're given is the rate of speed of the cars. They're not driving the same speed, or they would meet midway between the towns. One car is traveling faster than the other and will cover a greater distance in the same amount of time, and so the cars will meet closer to one of the towns. Let's say the faster car is starting at the first town and traveling this direction. It will go past halfway when it meets the other car. In the amount of time it takes the first car to travel that distance, the second car leaving this town will only travel this far, and they will meet at this spot on the road. We can model the distances traveled by those cars because we know the formula distance equals rate of speed times time of travel. Let's choose variables to represent the rate of speed of the two cars. For the slow car, let's use the letter R for its rate of speed. For the fast car, we can use the expression R plus 10 because we know it goes 10 miles per hour faster than the other. In the drawing, let's label the distances. The distance the slower car travels is its rate times the time that it's driving for. They start at 2 o'clock p.m., they meet at 5 o'clock, so it's driving for 3 hours. The distance traveled by the car is R times 3. Now let's label the distance traveled by the faster car. We take its rate of speed, which is R plus 10, and multiply by the time that it traveled, which was 3 hours. This expression is the distance covered by the fast car. This expression is the distance covered by the slow car. We know what those distances add up to, the total of 240. So let's make an equation. The R times 3, which could be written as 3R, plus the R plus 10 times 3, which could be written as 3 times R plus 10, equals 240. Let's solve this equation, first by doing the distributive property. 3 times R is 3R, and 3 times 10 is 30. Now combine like terms. We get 6R plus 30 equals 240. Now subtract 30. We get 6R equals 210. And then divide by 6. We get R equals 35. We figured out that the speed of the slow car is 35 miles per hour, and that the speed of the faster car would be 45 miles per hour. Now number 25. Said Bill to Mary, I earn just $25 less than twice as much as you do each week. If this extravagant couple needed a joint weekly income of at least $170 to make ends meet, what was the least that each of them had to earn to avoid debt? We need to figure out Bill's income and Mary's income. Let's represent Bill's income with the letter B and Mary's income with the letter M. Now read the paragraph and create equations. Bill says, I earn $25 less than twice as much as you. So Bill's income is equal to $25 less than twice Mary. That can be represented as 2 times M minus 25. The next sentence says, this couple needs a joint income of at least $170. So that means that Bill's income plus Mary's must be at least, or greater than or equal to, $170. Let's solve this inequality. But because it has 2 letters, let's replace the letter B with 2M minus 25. Combine like terms. 2M plus M is 3M. And add 25 to both sides to get 195. Now divide by 3. We get M is greater than or equal to 65. The question was, what was the least that each of them had to earn. We found that Mary had to earn at least $65. To figure out what Bill needs to earn, let's substitute the number 65 for M. 2 times 65 is 130, and 130 subtract 25 is 105. So Bill must earn at least $105. Next, number 27. A factory can produce 1 chair in 24 minutes and 1 table in 32 minutes. If it plans to turn out twice as many chairs as tables, what is the maximum number of completed units of each item it can produce in an 11-hour workday? So we want to know what's the number of chairs that it can produce in a workday, and what's the number of tables it can produce in the workday. Let's use the letter C to be the number of chairs and the letter T to be the number of tables. The number of chairs equals 2 times the number of tables. Another sentence tells us how many minutes it takes to produce 1 chair or 1 table. 24 minutes times the number of chairs plus 32 minutes times the number of tables will add up to the total number of minutes in an 11-hour workday. That's 11 hours times 60 minutes per hour, or 660 minutes. Let's solve this equation, but because it has 2 letters in it, let's substitute for the letter C. The letter C can be replaced with 2t. 24 times 2t is 48t. 48t plus 32t makes 80t. And then divide by 80 to get t alone. T equals 8.25. It doesn't make sense for the factory to produce 0.25 of a table, so let's round this value down to 8 tables. Once we know a value for T, we can substitute to find an answer for C. And we get C equals 16. So 16 chairs and 8 tables.